Okay, awesome. So now, and by the way, all my lectures and videos start with, oh, great, it's recording, or, oh, that's awesome. So having said that, I want to say one more time that if I'm on early and you log in early and I'm sitting here, feel free to ask me questions. I have no problem with answering stuff. I'm just killing time. Sometimes I'm looking over material, but most of the time I'm just killing some time. So having said that, what I want to talk about today is, well, I want to talk about programming some more, and Python in particular, but I want to talk about how we, if you haven't done so already, how you should download Python and install it on your computer. Now, does anybody have a Mac? Anybody in here?
I have a Mac.
You do. Have you
Yeah.
downloaded and installed it or no?
Yes, I have.
You have?
Yeah.
Okay, and so when you download it, you get the package, right? It's like a package thing. Is that right? Okay,
Yeah.
and then you just double click, because I don't have a Mac, so then you just double click on it, and does it install automatically, or do you then have to click on something else?
You have to like drag that package into like the application folder and then it starts installing. But yeah, basically that's all you do.
Okay. Okay. So is the package like a zip file? Is like a compressed file, or no?
I want to say it is. I did it like before class even like started, and I'm
Okay.
not at my computer right now.
No, that's fine. I was just wondering because, like I said, I'm PC only, except for my phone, but that doesn't really count because I don't do anything productive with my phone. So I want to talk about, and by the way, on page 526 and 527 of the book, so it's an appendix, it's at the end of the book, there's a section that talks about downloading and installing Python, and it's a little bit out of date. So it doesn't quite look the same way as the Python website does now. So let me share my screen and we'll go from there. Okay. So here's the book, Downloading and Installing Python. And so what we want to do is we want to go to python.org. So I'm going to go ahead and start a web browser. Oh, let me start a new web browser. How about that? And then let me put it on the appropriate screen. And then let me move my chat over to the other screen. It's endless screen management. And I'm just going to type in and do a search because Google is my homepage. So python.org, there it is. And the first result, by the way, if you look, is an ad. So I'm not sure why, well, I know why, because they're making money off of it. So I'm not going to click on that one. I want python.org, so I click on that one. And then I'm here, python.org. I'm going to go to downloads. I'm just going to click the downloads thing. And here it says, download the latest version for Windows. So if you are a Windows user, you just click on this link. This is Python 3.85. So if you click on this, it asks to save the file, which I will do. And basically it downloads the file to your downloads folder. Unless you've changed your downloads folder to somewhere else, some of you may have, it's going to be in your downloads folder. And there's a couple of ways to get to it. Now I'm in Firefox, so I have this little down arrow. If I'm in, that's Edge. Oh, it's not showing up because I haven't downloaded anything to Edge, but it's here. And notice that the keyboard shortcut is Control-J. In Firefox, it's Control-J also. So if I mouse over that, you can see it says Control J. For you Chrome users, I don't know if I have Chrome on this computer. Let me double check. I do not. Or is it under G maybe? Google? No, I don't. So I'm not using I don't have a version of Chrome. I'm almost positive that Chrome, to get to your downloads, you can also use Control J. In addition to, you know, clicking on the link. In Safari, I honestly have no idea. So I don't know if it's Control J too. I don't know. No, I don't think it is, because you guys have different keyboard shortcuts. But anyway, so all I do now is I go to my downloads folder. And now I've downloaded it a couple of times. So this is the Mac package. I downloaded the Mac version. And I guess you drag that into your applications folder. Is that what you said?
Yeah, I mean, it's pretty, it's self-explanatory. As you click the things, it just tells you what to do.
Yeah, because if I click it, it's not going to tell me anything because I'm on running Windows. So for the Windows people, you double click on this. Now it's just going to be the normal. It's not going to have a 2 or a 1 here because you haven't downloaded it a bunch of times. And then it's going to say upgrade to Python, and this is the 32-bit version. And I can click upgrade now. I'm not going to, because it's already installed on my computer. So I'm just going to hit cancel. Once you get that, oh, and by the way, if you are a Mac user, you got to go to Mac OS X, I think. Let me scroll down here and see what's going on. Now, you got to click on the Mac OS X, and then you can pick, I guess, this first one, September 8th, and you can click on the 64-bit installer. Most people should have a 64-bit operating system. I'm pretty sure all the newer Macs are 64-bit. Yeah, see, it goes back to October 9th, 2019, where there's a 32-bit installer. Oh, here's one, December 11th, for a 32-bit. That has to do with the operating system that you're running and whether it's 32-bit compatible or 64-bit compatible. You kind of have to figure that out. Oh, wait, here's a 32-bit installer. But then they stopped really doing 32-bit installers for the Mac. So I don't know. You can always try the first one and see what happens. If it doesn't work, then you need a 32-bit. Okay, so having said that, it's going to download the same way. It's just going to be a package file. So once I have it on my computer and I've installed it, oh, on Chrome, oh, that's right, on Chrome, your downloads appear kind of on that little taskbar down at the bottom. So let me go ahead and close my browser, and then let me go to my programs. So I'm going to click on my Start button, and I'm going to scroll down until I get to the P's, and there is Python 3.8. And really, we only need one of these. So I've installed both the 32-bit and the 64-bit version because I mistakenly did the 32-bit version first and didn't notice it for a while. But what I would just do is I would put one of these on the desktop. And all you got to do is have your desktop available. Oops, I went too far. And then all you got to do is drag it. So we want the idle program. So the idle version of Python. And if you read a little bit about Python, you know that there are two environments. One is a straight shell, and one is the idle environment. And the idle environment has the advantage of being able to work like the shell does, but also lets you write more complicated programs and save your work. So instead of trying to, jump back and forth between the two, you might as well just use the idle all the time. And so I just clicked and dragged it over onto my desktop, and now I have 3 shortcuts. There's another one on my other screen. I'm going to get rid of that. And I'll get rid of that one. I'm going to get rid of this one at some point too. And so let me just show you the idle. I'm just going to double click on it to start it. And this is like the regular shell. So this is like the other one, and I'll show you that in a minute. But here you can just type in commands and press enter, and it will run your line of code. So if I type, for instance, print hello world, oops, I forgot to do that. There we go. If I do that and I press enter, it will run and it will show you what the output of that line is. What does that line of code do? So it just shows me hello world. And the book uses just this shell here to show you examples of what it's talking about in the chapter. So for instance, let me go back to the book. And let me go back up to chapter 1. There's a lot in chapter 1. Okay, so where am I? Oh, come on. I got to get to chapter 1 first. There I am. So once he starts talking about Python, he should start giving me little things that I can look at or try out. Wow, he doesn't start talking about it for a while. Ah, here we go, Python Standard Library. I'm getting close to something. Maybe I'm not getting close. Maybe I got to go to chapter 2. Oh, there we go. Let's try it. So it says, from the Python shell, enter the following and observe the results. Now he's talking about numeric literals here. And so basically he's just talking about numbers and how Python works with numbers. So he's giving some examples, and then he says, go ahead and let's try it. So if you want to do that, you just go to your shell, and I should be able to type in whatever it is that he said. So if I do 24 and I press enter, okay, so if I do 1, 024 and I press enter, I get a syntax error. So the examples that he gives are examples, like in this case, he's talking about what's correct input for numbers, and we're not allowed to use commas for input because what? Here we go. Syntax error, leading zeros and decimal integer literals are not permitted, blah, blah, blah. So basically, it says it's starting 024. So the comma is screwing it up a bit. So anyway, so there's a lot of examples like that where he uses the Python shell just to give you, okay, so this is what we talked about, and here is what's gonna happen, or these are some of the issues that you could have. I'm trying to resize this, and for some reason my arrow keeps jumping. Come on, there we go. I'm trying to make it a little bit smaller so I can manage it. Now, so it works exactly the same way as the regular Python shell, except we can also create a more complicated, instead of just running a line or two of code and seeing what it does, we can create a more complicated program. And we do that and save it as a file. So I can say new file, or new, whatever the new is, and I get a new window, and you can see that this is an untitled file, and I can write code here. So what should I do? Oh, I know. Print. I'm not very imaginative. I forgot the quotes or the apostrophes around text that you would like to show. And the parentheses. And this is obviously, it's just one line of code. I could do this from over here, but I can now save this. So I'm going to go save as, and I'll give it a name. And I put all of my files that, oops, I put it on the desktop, in a folder called Python Programs, and I'll just go ahead and save that. And now it's saved. Now I can run it. And so this is the program running. Now, obviously, there's no user input here, so it just says hello world. That's what the program does. And I can close this. I can go back here, and I can edit this. So let's see, say I add a line, and I'm going to print something else. So I've added a new line of code to my program. I'm just going to click File, Save, and you can do Control S, so that works. And then I'm just going to run it. And you can see now, I can see the changes that I made to my program. It says hello world, goodbye world. That's the second line that I added. And I can close all of this. And my program is saved. Where is it saved? Damn it, it's saved over here. I just have to move stuff around. I apologize. Hello world 11. Now, one thing that's a little bit different is that if I just double click on this, it didn't actually save the way it's actually not doing anything, because it's just it's just running. So if I want to open this, you need to right click on it, because I want to edit it with idle. Okay, I don't want to just open it in the shell. So if I click this, if I right click it, then I can get back to the shell. Now, normally when we're working with a Word program or something else, we typically double click the file that we want to open, and it opens automatically where we want it to open. With the case of Python, it's a little bit, you have to right click on it and say open with, or you can just open Python. So I could do it the other way. Open the idle Python environment and click File, Open, and then just go to where my files are, and I can open a program, and then I can run it. So for instance, here is a Magic 8-Ball program. And basically it's conforming to kind of the 4 steps or the 3 steps of writing a program. The first step is to kind of explain what it is, Magic 8. Hello world, I am the Magic 8-Ball. And then it's asking me for input. That's getting user input is the second step. So this is going to ask me for multiple pieces of input. So this is a command line system. We don't typically have fixed user interfaces in Python. So it's asking me what my name is. So I'm going to put in Bob and press enter. And then it says, hello, Bob, ask me a question. So now it's prompting me for more input. So I'm going to say, will we ever have classes on campus again? And just to be grammatically correct, I'm going to put a question mark there. Now, I didn't need to. Will we ever have classes on campus again? And so I'm shaking the 8-ball, and now I'm going to turn it over and see what my result is, and I'm going to press enter. Outlook good. Oh, good. The Outlook is good. Do you have another question? And I can either input Y or N, and in this case, it's case sensitive. So if I do a lowercase y, it says, I apologize, I didn't catch that. Please repeat, right? So I'm going to do Shift Y and press enter, and it says ask me a question again. So it's prompting me for input, and I'll say when. And then it's a Magic 8-Ball. So Magic 8-Balls give you answers that don't make sense, and this one doesn't make sense. Now, at some point, I can press Shift No, I do not have another question, and it will close the program. Okay, so anyway, there's my Magic 8-Ball. So let me go back into chapter 1. I would like to make sure that everybody has Python installed and it's working the way it's supposed to. You don't have to do it now, but try to have it done before Thursday. That way, if we have any individual issues, and by the way, if you do have an issue now, you can let me know, because we can always share screen. This is not one of those issues where an email is good enough. This is one of those issues where I need, if you have issues, I need to see your screen to see what issues you have. So I know that a lot of you just want to send me an email and say, ooh, why isn't it working? Well, beats the hell out of me. I don't know why it didn't work. So, and by the way, a lot of programming is like this. You can send me code in emails and I can look at it and see if that helps. But it's easier for me if I just see stuff on the screen. So where did we leave off? Did we talk? We did talk about the goat and wolf problem, didn't we? Oh, my chat isn't up. I'm sorry. Where did it go? There it is. Yes, we did talk about it. Okay, I thought so. So that's one of the examples that the author uses to illustrate how computational problem solving, how we go about it. And there's a whole section on that. So what I want to talk about now is I want to talk about, I'm going to skip some of this. I'm going to get back to it on Thursday. We talked about what computer software was, but I want to talk about, it's down here. what we need to do in order to, create a program. So the first thing we do is we analyze whatever problem. So what is it that I want the program to be able to do? So we analyze that, and then we have to come up with, okay, so what is a real solution to that problem? Then I have to determine or figure out what it is I need. So what is it that I need to do? So if I need to write an equation or 2 or 5, what is the data that I need to keep track of? What do I need to multiply, divide? Do I need to, what calculations do I need to do? How is it going to be structured? So what order do I need to do things in? That's one way of thinking about structure. Thirdly, we need to implement it. So now I need to take that theory and I need to apply it to actual programming. And so, like if I need to represent the man and the cabbage and the wolf and the goat, how do I actually do that in a programming language? So what's the correct syntax to do that in? Or what makes logical sense? And then we write the program and we test it. We see if it works. Always test your programs, especially programs that do calculations, with numbers where you know what the answer is going to be or should be. And don't just do it once. We tend to do, the extremes. So we test to see abnormal or extreme cases where somebody is entering, right? If we're doing a calculator that's going to add 2 numbers together, I need to make sure that it works with extreme numbers on both sides. And then we do a couple of kind of regular calculations. So what's kind of a normal calculation? What would most people be doing? So when you're using a calculator, what are the kinds of calculations that most people would be doing? But also look at what are some extreme ones, because we want to make sure that the program functions equally well for both. And by the way, a lot of times it can, I would do fractions or negative fractions or decimal places, long decimal, 2.3456, negative 2.34567. Times blah, 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 blah. And then if I get the right answer there, then I'm probably okay with, 3 times 5. That's probably going to work. And we do a couple of those too. 3 times 5, 5 times 4, 6 times 6, and make sure those work also. So testing and debugging is very, very important when it comes to creating programs. Now, having said that, I want to talk about Python in particular and programming in general still. One of the steps to actually creating a program is to, once we've figured out some of this stuff, once we get to the implement the program step, we have to figure out what programming language to use. And that step we don't actually have here because we're going to use Python. That's what the class is about. Well, that's what we're using in the class. So we need to learn Python a little bit. And whenever you're learning a language, there are 2 things that we really need to learn. One is called the syntax, and the other is called the semantics of a language. So the syntax of a language is, for instance, if I use English as an example, the syntax of the language consists of most of it. So what letters do we use in English, right? We use the ABCs, the regular characters, Western alphabet. We don't have any special symbols that we use in conjunction with that, because I know in Germany they have the 2 dots that go over like a U. In other languages, they have like accent kind of letters or characters that are part of the alphabet. Actually, I don't think that's part of the German alphabet, but they do use it when they write. So that's part of the syntax. How we spell words, for instance, is also part of the syntax. What is a word? Right, so not only how do you spell it, if I want to spell the word have and I type H-A-V, my syntax is incorrect because I spelled it incorrectly. But also a nonsense word like T-Z-Y, that's not a word at all. It's not spelled incorrectly. It just doesn't exist. So that's also incorrect syntax. And the proper way to write things that have context is semantics. So where is that? There's a section in here about syntax and semantics. Semantics is basically, where is it? I should just do searches, shouldn't I? Is basically how we put words together. Oh, there we are. So this, for instance, right here, oops, is incorrect syntax because how, H-A-O, is not a word. Let me zoom in a bit so it's easier to see. I am sharing my screen, right? Yes, I am. This, on the other hand, colorless green ideas sleep furiously, is the correct syntax, right? Every word here is spelled correctly and is an English word, but semantically it's incorrect. And why? Because this is just a bunch of words put next to each other. It's not an actual sentence. It has no meaning. And I can't even infer a meaning. So the semantics has to do with the meaning associated with a sequence of characters. So is there meaning? Okay, so hopefully that makes sense. Now, syntax errors are easier to find because what will happen is when we create a program, it won't work the way we want it to. Or it may not actually run, so you may get an error right away. And so if I type print incorrectly, for instance, that's a syntax error. So if I type pint instead of print, right, and then I try to do hello world or just hello for the sake of speed, and I press enter, you can see that it didn't do what I thought it was going to do. The print command is how we display something in Python. So what does it say here? Python shell line 1. And it's telling me that pint is not defined. And what that basically means is that there is no set of characters. In this case, it's a word print, but in some cases, it's like a /n or something like that. There's no set of characters in the Python language, P-I-N-T. There's no such thing. So that means it's not defined within its language. The word the in English is defined in English. The word TEH, on the other hand, is undefined. There is no such word. So we can just look at the word defined here as being, does it exist or not in the syntax of this language? Does that make sense? Okay, so those are relatively easy to find, those kind of mistakes. Semantic errors are a lot of times called logic errors. And I'll give you a logic error is where we created a calculation that the program is supposed to do, and it gives me a result, but that result is incorrect. So there are two reasons why. Well, there's only ever one reason why. It's our fault. We probably created the formula, the calculation. We did the math wrong. We programmed it correctly, right? We entered the formula correctly, but it's not the formula that I need to use because I'm getting the wrong answer. Does that make sense? Like if I create a little calculator program where I have the user enter two numbers and I say to the user that this is going to multiply the first number by the second number, but instead when I press, calculate, or I press the enter key and it's supposed to give me the answer, and let's say I enter 5 and 3, so it's supposed to multiply it, but it doesn't. It adds it. It gives me an 8. So that's a logic error. The math I wrote is correct. It works. But it's supposed to be multiplying when I'm adding. And so the answer that I get is incorrect. That's what a logic error is. And logic errors are very difficult to find. It's kind of like spelling errors. Like if you create a Word document and you type it all up, and let's pretend that there was no spell check button. And then you print it out, and this is how we used to do things when we had typewriters. You'd have to type it up, and then you'd proofread it. Actually, before you typed it up, you wrote it out by hand, which nobody ever does anymore. So you'd write it on a piece of paper. And why do you think we wrote it on a piece of paper? And Patrick, you are not allowed to answer because you know why. Why did we write it on a piece of paper before we typed it in a typewriter? He asked his attentive class.
Because there's no delete button on a typewriter.
Okay, which means what?
You can't mess up.
What can't you do once you've typed it? You can mess up. You can mess up in Word too. You can't do what?
You edit.
Edit it. You cannot edit what you've typed. And I know that's what you meant, but I'm trying to be precise. We have to be precise. We're going to start talking about programming, and we need to be precise. Try to be, and by the way, this is the hardest part of learning programming. It's not actually learning the language. It's not the syntax and semantics of Python as opposed to C++ or Visual Basic. That's not the difficult part for most people. The difficult part is trying to break our thinking down into little logical units and then put those in the right order. And the other difficult bit is being precise about what it is that we need to do. What exactly do I have to do, right? And so when I talk and lecture, I will try to use very precise words. So one thing that you can't do once you've typed something is edit it. So why waste all the time to type it up first? Go ahead and write it out on a couple of sheets of paper. And so we used to write papers by hand. And then we would edit. So I would say, you know what, I'm going to circle this paragraph and draw a line. I want to move it to down here. And, ooh, I need to check the spelling. And we used to have a book called the dictionary. And still, it's very difficult. So what we would do is we would give it to somebody else to proofread, which, by the way, is you still should do. You should always have, if you're taking what's the capstone English class, you should always have people proofread your stuff, because those professors are hard ass. At least they were when I was in school. But my point is because it's easier for somebody else to see our spelling mistakes than it is for us to see our own spelling mistakes. Why? Because we obviously don't know how to spell that word. So why would I go, oh, is that spelled incorrectly? I may have an inkling, oh, maybe I didn't spell that right. How do I, and then I look it up. But for other words where I just don't know I spelled it wrong, I'm not going to find it, even though they are spelled wrong. So somebody else will much more easily see, hey, you spelled this wrong, and circle it, right? And then you go ahead and edit it, and you move your stuff to where you think it should be. You add things, you cut stuff out, and then when you're completely done editing and you're happy with your document, that's when we used to get out the typewriter and type it up and try not to press the wrong button and misspell a word because we pressed the wrong button on the keyboard. Nowadays, we just edit everything. We make mistakes. We let Word run our spell check and our grammar check for us. And life is a lot easier because I can add, subtract, move around things very easily. And we can do all kinds of other formatting. So what does that have to do with programming? Well, logic errors are kind of like those spelling errors. We make an error in logic because I did the math incorrectly because I don't know how to do the math correctly. So how can I fix my own problem? Again, when we test programs, we should always run it, especially programs that calculate stuff. We should always run it with numbers that we already know what the answers are going to be. And by the way, here's another rule of thumb. You really can't create a program. You can't create a program, for instance, that multiplies numbers unless you can multiply, unless you know how to do it. So you can't create a program that will figure out how much of a tip you're supposed to leave unless you could take a piece of paper and I could say, well, how would you do that? What's the math to figure out what kind of a tip to leave? If you can write it on a piece of paper and figure it out and show your work, then you can create the program. If you don't know how to do the math, you can't write the program to do it. So my last, I'm going to say it one more time. If you don't know how to do it, you can't write a program that does it for somebody else. The end user, they don't have to know how to do an average. They just have to know how to use the program that spits the average out to them. But the person who created the program has to know the math behind doing an average. Does that make sense to everybody? And my chat room is gone. Here it is. Okay. So that's why logic errors or semantic errors are harder to find. I'm going to get back into this on Thursday. But I want to talk about basically the 4 things that we do, especially when we are doing calculations. And by the way, even if we're not doing calculations, even if I'm doing a very simple program. So let me tell you the steps. In order to do that, I'm going to stop share and I'm going to share my whiteboard. What time is it? When are we done?
At 150.
At 1:50?
Yeah.
Are you sure?
Yes.
Are you positive?
Yeah, 150.
Okay. I believe you. I'm just giving you a hard time. That's all. So, what was I going to do? I was going to share my whiteboard. So I got about 5 minutes. So here's my whiteboard, and I'm going to move this over here. And so, even when we're not doing calculations, but I'm going to go with a program that does calculations. We really have, well, 3 steps. And the 0th step, okay? And this isn't really optional for the most part, this step here, but sometimes it is. So there are really 4 steps. I know I said there are only 3, but so the first step, or the 0th step, is to create a welcome. So welcome the user. And by the way, our programs don't really have a user interface like Word does. That's what I always liked about Visual Basic, is that we can create a user interface with buttons and all kinds of stuff. We can do that in Python, but it's a lot more work. So what we typically do is we create some kind of welcome. And that welcome includes any kind of instructions that the user should have or needs to be aware of. And then we get into the meat. So then the real first part is we get the user input that we need. And most programs require some sort of user input because we're typically figuring something out. So in a Word document, the input is typing stuff up, right? So we actually input the words and the sentences and the paragraphs. And it depends on the program what the input is and what we're going to do with it. And we'll talk more about that at some point. So that's 1. 2, we do our calculations. So, or we do our processing. Whatever it is that we need to do to the input, we do. So a lot of times that's doing some math or doing multiple pieces of math. So we do our calculations after we get the input. And then thirdly, or lastly, I should say, we display our results. And by the way, we display our relevant results. This isn't as easy to do as I thought. Writing on this damn white. It doesn't look as good as I thought either. By the way, when I'm standing in front of a traditional real whiteboard, it doesn't look much better than this. I just noticed it. So we display the relevant results. And one of the ways that I can illustrate that is to think of when you have to do an average of a set of numbers. So we have to do multiple calculations, right? The first is to add all of the numbers together. The second one is to count how many numbers there are. And the third one is to divide the sum by the number of numbers, and that gives us our average. But if I'm creating a program, I have to do all of that processing, calculating, but I really only need to display the relevant result, which is the average itself, my final result, the average. Does that make sense? So I have to do all of the math and I have to write the code to do all of the math, but I only need to display one thing back onto the screen, and that is the average. So hopefully that makes sense. And now I'm going to show you a program. I think it's the Drake program. Basically, this program, oh, damn it. So give me a second. I know that I'm a minute over. Come on, I got to move this and I got stuff on top. Oh, I got to share my screen. Sorry. Stop sharing this. Stop share. Share. I'm hurrying. There we go. And then I'll move this. And I'm going to open my Drake program, the Drake equation. And basically what this is a program that will estimate how many, by the way, the Drake equation is an equation that estimates how many, the likelihood of finding intelligent life in our galaxy. And so you can see here that in my program, I have created a little welcome bit. Welcome to the SETI program. It actually says welcome. This program will allow you to enter specific values related to the likelihood of finding intelligent life in our galaxy. All percentages should be entered as an integer. Obviously I left out the N here, as integer values, e.g. 40 and not 0.40. So, and then I'm on to step 2, which is gathering my input. So here I'm already asking the user a question. And it says, what percentage of stars do you think have planets? So let me go high here. Let me go, let's say 30% of all stars. Oops, I got to click over here, sorry. 30% of all stars have planets. Now, I'm gathering user input. So the 30 is user input. I press enter, and I'm gathering more input. You can see I'm asking another question. How many planets per star do you think can support life? So Mars is a bit iffy. It could probably support life if we did some little stuff to it. So let's say 2, and I'll press enter. What percentage do you think actually develop life? So what percentage of the 2 planets? So let's say 50%. What percentage of those do you think have intelligent life? So let's say 60%. I'm just going to be optimistic here. And I'm pressing enter. And see, now I am gathering multiple pieces of input from the user. How many of those do you think can communicate with us? So let's say that I go 60% of those could communicate. And then the last question here is the number of years you think civilizations last. So how long have we been around on the planet? I don't know, 10,000 years? So maybe we'll last another 5,000. So let's say 15,000. And I will press enter. So what happened when I pressed enter is all of the input that the program gathered had a calculation done to it, or had calculations done to it, and I came up with the answer. And then I displayed the answer back into, to the user. So here it says, based on the values entered, there are an estimated 11,340 potentially detectable civilizations in our galaxy. So, and I spelled galaxy with a Z instead of an X. So there are a couple of issues. Those, by the way, are English syntax errors, because they're spelling errors. There's no such word as galaxy right here. So you can see that this program is following those 4 steps. And we'll look at under the hood of this at some point. We'll look under the hood of a lot of programs. What I would like you to do for Thursday is to look at chapter 1, maybe read the beginnings of chapter 1, because that's what we're going to talk about. We're going to talk about some general stuff, and we're going to talk a little bit about some Python things. I may give you next Thursday, or this coming Thursday, I may assign a program that you have to do. I'm not sure yet whether I'm going to do that or whether we're going to wait till next week. I know the syllabus says next week. I think we probably will, but maybe I'll have you do a little one. But anyway, that's beside the point. So if there aren't any questions, if you do have questions, I will stay here. If you don't have any questions, then